My name is Cord Sangsteak. I'm a design engineer here at Sheldon Manufacturing. Today, I'm going to be introducing the Bactrox Hypoxia Microaerophilic Chamber. It provides an advanced solution designed for precise oxygen control and a variety of research applications. This product is engineered to provide controlled oxygen environments ranging from 1 all the way up to 20%, making it ideal for researchers studying cell culture, microbiology, and hypoxia-related processes. Let's take a look inside the unit. The first thing you will notice is the pass box. This feature is designed to seamlessly introduce samples or components into your chamber without disturbing the atmosphere inside. Behind the inner door, you will see the oxygen sensor. This is linked to the display up here that we'll mention in a second. Behind that is the CO2 sensor, also linked to the control panel up here. Below that, you will see the convenience outlet designed to allow you to use any electronic devices inside the chamber that you want to have while it's running. In the center, you will see the incubator. This is the temperature-controlled region of your product, and it allows you to set a precise and uniform and stable temperature within to incubate your samples ideally. Let's take a look at the left side of the unit. There are 4 gas ports located here. The first of which is your CO2 gas supply. To the right of that is the nitrogen gas supply. Then you have the sample port. This allows you to hook up your own device to monitor the chamber atmosphere as you see fit. Moving one over is the oxygen calibration port, which you will use upon installation to calibrate the oxygen sensor located inside the chamber. Right here on the left side of the control panel, you will find the digital communications port you may use for data logging. Looking at the back of the unit, there are 3 more features to discuss. First, you will find the main electrical inlet. Each unit must be connected to a properly grounded electrical outlet using the included power cord with every unit. This features an externally located fuse drawer to allow the end user to replace the fuse if they do need to. Moving below, you will find the vent. This is linked to a solenoid valve inside the unit that will vent chamber atmosphere if it needs to. Moving over here is the muffler. This is linked directly to the chamber atmosphere, and this is the primary outflow of the gases inside the chamber. It features a push-to-connect fitting should you want to take and ferry those gases somewhere other than the ambient atmosphere. After connecting the unit to a properly grounded outlet, it is ready to be turned on. For information related to electrical safety, as well as installation instructions, including clearances, please refer to your user manual. The main power switch is located on the left side. Turning it on, the control panel functions become available. The first display that you will notice is the temperature display. This allows the user to set and calibrate the temperature within the incubator. To the right, you will find a standard over-temperature limiter. This allows the user to cut off power to the heating elements should an over-temperature event occur. Moving over, you have the gas displays. First is the oxygen display. This allows the user to set, calibrate, and adjust their desired oxygen set point within the chamber. Over here, you see the CO2 display. Similar to the oxygen display, it allows the user to set, calibrate, and adjust the CO2 level inside the chamber. Moving over here is the pass box switch. This initiates the cycle for the vacuum pass box should you want to introduce any samples or devices into your chamber. Last but not least is the light switch. This allows the user to turn on and off the light as they see fit. The base Bactrox model is a countertop design. However, stands are available for purchase on rolling wheels. Please visit our website for a full accessory list or the user manual to figure out which one you need to get. The Bactrox Hypoxia Microaerophilic Chamber features precise oxygen and CO2 control, reliable performance, and an ergonomic and user-friendly design. This product is ideal for industries including cancer research, infectious disease studies, biomedical engineering, and human respiratory pathogens, making it a valuable tool for cutting-edge scientific research and advancements.